G'day team, welcome back to another video, and today we're going to start exploring something known as the natural log. Now, to explore the natural log, we sort of need to have a bit of an idea of what a natural exponent is. So we have a little formula here, and now if you've done any form of financial maths, you might recognize this as a bit of a compounding interest formula. Now, as this a value increases, so I've got a whole range of examples, we can see that if I put in a equals 10, this little formula becomes 2.5937. Now, if I make a 100, I get 2.70481. So it's changed slightly. If I put in 1,000, it's changed even less. We're only at the second decimal place now changing. 10,000, we're only at the third. And then 100,000, we're at the fourth. 1,000,000, we're at the fifth. So we're getting closer and closer to this crazy number. Now we say that this is converging on this number. And no matter how big a goes, we'll get closer and closer to this number, but we'll never equal that number. It's a little bit like pi. It goes on forever. So this is something called the natural exponential, and is a value like pi, like I said, but we actually give it a name as well, and we call it E, and this is named after Leonhard Euler. Okay, so a very famous mathematician. So we have a new irrational number E, which is 2.71828, and goes on forever, just like our friend pi. Now, you're probably thinking, why am I telling you this? We've been doing logs in base 10, we've been doing logs in base A, but now we're going to start looking at what happens when we have logs of base E. And this is where the idea of the natural logarithm comes from, because it's the log with the base of the natural exponent. So the logarithm in base E is called the natural logarithm. So we would represent this typically as log base E of x, but we're going to shorthand it so we know straight away it's the natural log, and we're going to call it ln of x. Now you may see this button on your calculator, which is a good thing. We're going to use that quite a bit. So that's called the natural logarithm. Now I have two sort of rules that we can use. So the natural log of e to the power of x is equal just to x, and e to the power of natural log of x is just x. So if we see these in our expressions, we can really simply simplify them. All right, so we're going to have a little bit of a practice at that. So simplify these two things here, or three things. I've got three. So if we're looking at this first one, a, I've got the natural log of 1 over e to the power of 2. But we want e to be to the power of something on the numerator. So we've done lots of practice with negative indices, so we know we can rewrite this as the natural log of e to the power of -2. Now this looks like our first option here, so we can say that it's just equal to our power, which is -2. All right, easy as that. Now b, it's already in the form we want, and it's like the left hand side, so we know it's just equal to 3. And finally, this last one, it's a little bit trickier because we've got this weird little 3 out the front here. But I'm going to make you just think for a little bit. If we're thinking back to our log laws, our natural logs kind of act very similarly. So what we can actually do is take this 3 up the top here. So we've got e natural log of 9. And now it looks like this. So we can say this is equal to 9, okay? And I've even got one more in here. Now we've got the same base multiplied together, so we know we add the powers together. So I've got e to the 3 plus p. And now I've got that first option again where I've got natural log e to the power of something, and we know that's just equal to the power. So we bring the whole 3 plus p down. All right, so just like I said a little bit earlier, the laws for the natural log are the laws for logs, but just written in base E. So a little reminder, we've got the natural log of m plus the natural log of n, and we just multiply m and n together. M minus n, we get m divided by n. And like I said, we've got our power out the front that just can jump down or jump back up. Now, the natural log of e is equal to 1, and the natural log of 1 is equal to 0. So in the last video, I used log 10 to represent 1 most of the time. When we've got an equation or an expression with natural logs, we use the natural log of e. So let's do some examples. So I've got 3 times the natural log of 2 plus 4. Now we want all of those terms in terms of the natural log. So let's write this as the natural log of 2 plus 4 times the natural log of e. And then we're going to put those in brackets to make it super clear. We've now got a number out the front. Let's bring those in as a power. So 2 to the power of 3 plus the natural log of e to the power of 4. And when I have 2 natural logs added together, we multiply the inside. So the natural log of 8e to the power of 4. And I'm missing my equal signs. And we're done. Part B, negative natural log of 1 over 2. So it might not look like there's a number at the front, but we've got negative 1. So we can bring that up to the top. So natural log of a half to the power of negative 1. Now, a half to the power of negative 1 is actually just ln of 2. Okay, so that's all simplified. And then I've got this one here, the natural log of 12 minus the natural log of 4 minus the natural log of 3. So we know when we're subtracting natural logs, we divide the insides. So I've actually got the natural log of 12 divided by 4 minus the natural log of 3. We can do it in separate parts. So this is the natural log of 3 minus the natural log of 3. Now, we kind of can go 2 ways here. We can do option 1, which would be the natural log of 3 over 3, which equals the natural log of 1, which equals 0. Or option 2, a much simpler way, the natural log of 3 minus the natural log of 3 is just 0. We take something away from itself, it's 0, okay? But it kind of shows our 2 laws, or 2 of our laws working together, all right? Hopefully that helps a little bit with natural logs, and we'll see you guys in the next video. See you.